So we are going to study two topics under this. First is partial differentiation, like how to find the partial derivative for the function of two or three variables, and then we will see how to solve partial differential equation. As there are several methods of solving the partial differential equation, we restrict ourselves to the integration method. So to define partial differentiation, first we should know about the function of two variables. So a function of two variable is what? What do we mean by a function of two variable? A function of two variable is a rule that assigns to each order pair of real number xy in a set D in a unique real number denoted by fxy. Okay, the set D is the domain of f and its range is the set of values that f takes on. That is, this is the domain. So here now function will be changed depending upon two variables x and y. So the value of function is getting changed with the change in the value of x as well as in the change in the value of y. So for example, if we consider the temperature at any point of the surface of the earth, then temperature depends upon the longitude and the latitude of that point. So suppose if we denote the longitude by x and latitude by y, then temperature is a function of two variables x and y. As we change the longitude and latitude, the temperature becomes changed. Similarly, when we talk about the volume of a cylinder, it depends upon the radius and height. So if we are denoting the radius by r and height by h, then the volume is given by pi r square h. So it's depending upon r and h. Like if this is a cylinder, okay, with a radius r and height h. Radius is r, height is h. Now if I change the radius, what will happen? If I change the radius, suppose this is r dash. So what will happen? The volume, the size of the cylinder will increase and so does the volume. Similarly, if I make change in the height, if we change the height, this is h, suppose we increase the height, then what will happen? The volume will again get changed. So that's why we say that volume of a cylinder is a function of two variables r and h. Okay, so in this way you can give the several examples where you talk about the function of two variables. Now we talk about partial differentiation. How do we define the partial derivative? So for partial derivative, as I said, it should be a function of two variables or three variables. So let's first define for the function of two variables. Let's assume f is any function of two variables x and y. So as f is a function of two variables x and y, it means the values of f will get changed with respect to x as well as with change in x as well as in y. Then we define the partial derivative of f with respect to x as limit h goes to 0 fx plus h y minus fx y over h. See, we got this from the basic definition of the derivative. So if you remember, when y is a function of x, then we define f dash of x or dy by dx as limit h goes to 0 fx plus h minus fx over h. So to see the changes in the value of x, what we are doing, we are changing the value of x and then calculating the value of the function at these 2 points, taking the difference divided by the difference in the value of h. So derivative is defined as the limiting value of this term. So similarly, now when we are looking for the partial derivative of f with respect to x, what we did? Now f depends upon x and y. So we made change only in x. So we got the value of the function when x changed to x plus h and y same, and minus fxy divided by h. Now here h represents the change in the value of x. So this gives you the change in f with respect to x, which is nothing but the partial derivative. Here we are calling it as partial derivative because we are getting the partial change in f with respect to change in x, because f can change with change in y as well. So now what you can observe that the variable y remains same. So we are finding this thing by considering y as a constant. So this is how we define the partial derivative of any function with respect to x. Okay. Now, similarly, if we want to define partial derivative of f with respect to y, this is how we define it. This time, now as we are finding the derivative of f with respect to y, so we make change in the value of y. So y changed to y plus k, okay, and divided by the difference. Here x remains constant. X is considered as a constant value. So this is how we define the derivatives. Now we are using this representation to denote the partial derivative. Like instead of writing d, we use this notation which is pronounced as partial. Okay, it is also pronounced as del or curl. Okay, so we can denote it like this. So we use d by dx to represent the total derivative, and we use curl by curly x, partial by partial x to denote the partial derivative. Okay, another way of writing is f to the base x, means the derivative of f with x. Another way, similarly, when we are differentiating with respect to y, we denote it by partial y of f, or we represent it by fy. So we say when we talk about we need to find rate of change of f with respect to x, we say that it is partial derivative of f with respect to x. When we need to find rate of change in f with respect to y, we call it as partial derivative of y. Okay, and we keep the other variable as a constant. For example, if we have this function f as a variable of function of two variables x and y, x square y. Now if we want to find the change in f with respect to x, so what we will do? We first of all denote it by partial x, which is d by dx of x square y. Okay, now here, what we have to do, we know that when we are doing this thing, we are finding the change with respect to x, we need to consider y as a constant. So the only function that, since y is a constant, we keep it same. So the only term that we need to differentiate here is x square, and we use the normal rules of derivative to find the derivative. So derivative of x power 2 is 2x. Okay, by using the rule, we know that the rule for derivative for x power n, it is n x to the power n minus 1. So this rule we used and we got the derivative. Okay, similarly, when we want to find derivative, partial derivative with respect to y, we consider x as a constant. So when we are differentiating, so x square is a constant, we keep it constant. And we know that if we want to apply this rule for n is equal to 0, n is equal to 1, so what it will give you? 1 x to the power 1 minus 1, that is 1 x power 0, which is 1. Now we are going to use same rules of derivative as for y as we used for x. So we say that derivative of y is 1. So what we did here, we just differentiated y and its derivative comes out to be 1. 1 into x square is nothing but x to the power 2. If we look at the second function u, which is function of x and y, it is sine x over 1 plus y. So again sine, u is sine, and sine is again a function of, sine is in both terms, both the variables x and y. So when we want to find the derivative with respect to x, we have to make use of chain rule, right? Because without chain rule, how we can solve? Because here it is depending upon both. So another way of writing is, we can write it as sine of x 1 plus y to the power minus 1. I hope you remember chain rule, how to work with it. So when we need to find the derivative with respect to x, so what we will get? Sine x over 1 plus y. So by using chain rule, what we will do? First we differentiate sine. So derivative of sine is cos, the argument remains same, multiplied by the derivative of 1 over x over 1 plus y. Okay, if you remember, when we were having, say, sine of 7x, if we need to differentiate this one, what we are doing? Derivative of sine is cosine, the angle remains same, times the derivative of 7x. So it is cosine 7x times 7, because derivative of 7 into x is 7. We use the same concept here. Sine become cos, the argument remains same, times the derivative of this argument. Okay. So now as this is the term, we need to differentiate with x, although it is a quotient of two terms, but denominator is not having any x. So it remains same. We don't need to use quotient rule here. It's like when you have, say, x over 3 and you want to differentiate it. So you will simply write 1 over 3, because denominator is independent of x, derivative of x is 1. So this is how we find the partial derivative of u with respect to x. Note that what we did, we kept here y as a constant. Similarly, this is how we can find the derivative of u with respect to y. Now here we are going to treat x as a constant. So now again sine involves both x and y. So we should differentiate sine to cos, angle remains same, times the derivative of the angle. Okay, x over 1 plus y. Now how do we differentiate it? Now you have two ways, either use the quotient rule or consider it in this way. So if you want to differentiate it with respect to x, you get x derivative of x as 1, so 1 plus y to the power minus 1, which is nothing but 1 over 1 plus y, which is the term you got here. And when you have to differentiate it with respect to y, what you will get? You will keep x same, then differentiating this by using power rule, it gives you minus 1, 1 plus y to the power minus 2 times the derivative of 1 plus y, which is 1. So this gives you minus x 1 plus y to the power minus 2, which you can further write as minus x over 1 plus y to the power 2, which is nothing but this term with the minus sign. Okay, so this is how you find the partial derivative.